Hello and welcome to my KS2 Maths practice videos. These questions have been taken from the Collins Shanghai Maths project book. So let's get started. The first question is calculate the areas of the composite shapes shown below. Okay, so what we have here is we have these combination of rectangles, and so these sides, so this is 3 and this is not, this will be 7. 7 and 3 is 10, so this will be 7 as well, and this will be 6 plus 5 equals 11. So the total area is going to be 6 times 3 plus, so that 6 times 3 is this one, and this one is going to be 7 times 11. So the answer is going to be 18 plus 77, that is 15, 5, 1 is 9. So the final answer is 95. So unit is centimeter, so we have to write centimeter squared. Next one is 6, 8, 10. So what we have here is for the next one, this is going to be 7. So if we do the rectangle, the area is going to be 7 times 10 equals 70. If we do the triangle, it will be half base times height. So this is the height of the triangle, okay, and this is the base. So 8 is the height, this is my height, and this is the base. So it's going to be times 8 times 6, so that is 2 times 3, 8, 24. So the area is going to be rectangle. This whole thing is minus the triangle, that is the required area. So it's going to be 70 minus 24, okay, and that equals 6 and 4, 46 centimeters squared. The next question, as shown in the diagram below, the two heights of parallelogram ABCD are 15 centimeter and 18 centimeter respectively. BC is 24 centimeter. What is the length of CD? So this is the length they are expecting us to find out. Okay, so what are we going to do here? We will know that the area of a parallelogram is base times height. You can also write this as parallelogram equals base times height. So what we have is, we have the base, which is 24 for ABCD. So for ABCD, we will have base is 24 times 15. That is, if I do 24, 15, 2, and 20, and then 24, and then 0, and 6, and 3. So I get 3, 6, 60, And then what I want to do is we have to find out CD. So if we turn the parallelogram so that CD becomes the base. So if I turn the parallelogram so that CD becomes the base, then what happens? So what will happen is, see if we redraw the parallelogram now, so we will see that CD is the base, and this is A, and this is B. Okay, so if CD is the base, then AD, then this is 18. The height is 18. So this is, we extend the CD line, and this becomes the height, and this is 18. Okay, so we know the area of the parallelogram is 360. So it will be 360 equals base times height. Now they've given us 18 times base, which is CD. So 360 divided by 18 equals base CD. Okay, so 18 times 2 is 36, 20. So this is going to be 20 centimeter. The base CD is 20 centimeter. Okay, next one is a diagram on the right. My apologies for this shape of writing, but I hope you understand the question. The diagram on the right shows a composite shape made up of 5 identical squares with side length 5 centimeters. So each of these squares have 5 centimeters. So this is a 5 centimeter, this is 5 centimeter. Right, so there are 5 squares, 1, 2, 3, 4, 5. So there are 5 squares. Okay, now what have they said? Now if you look at these, the shaded diagram, you will realize that they are also parts of a square. So that is how I have done it. They are parts of a square. So because they are joining corners, straight lines joining corners, so they are parts of a whole. Okay, so the next thing is there are parts of the shaded diagram is parts of a square, parts of the square, right? So so 1 and 2. So this part gets here. So 1 plus 2 equals 1 square. And if you look at this one, see this is also part that fits in. So 1, 2, 3. So 1 and 2 and 3. They together form 1 square. 2 plus 3 equals 1 square. Okay, so what we have is there are 2 squares. So 2 squares. So the area is area of the shape. So the area is 2 times 5 times 5, that is 2 times 25, so equals 50 centimeters square. So the answer would be 50 centimeters square. Okay, the next one is, look at the diagram below. The side length of a square ABCD is 5 centimeter. BE is 12 centimeter. How much larger is the area of triangle CEF and the area of triangle AFD? Right. So, what are we going to do here? So, let us go to the question one more time. They're saying that the side length of a square ABCD is 5 centimeters. So this one is 5 centimeter, right? Then BE, or this one, the whole thing, is 12. So if BE is 12 and this is 5, so this must be 7. So CE is 7. So BC equals 5 centimeter. CE equals 7 centimeter. And what we get is how much, their question is how much larger is the area of the triangle CEF than the area of the triangle AFD. So we have CEF, which is this one, and AFD, which is this one. How much larger is CEF than AFD? That's the question. They haven't asked what is the area, they've asked how much larger it is. Okay, so how do I go about doing this? Now let me keep this will help us. So this is 5 and BC, and this is 7. So that's the measurement we have. Okay, so if we look at the triangle ABE, if we look at the triangle ABE, the area of this triangle is going to be half times base, which is 12, times height, which is CD. The CD is the height of this triangle. No, AB is the height of this triangle. Sorry, what am I saying? So this is the triangle we are looking at. Okay. So ABE, so half times 12 times 5. Okay. So base is BE, which is 12, and 5 is AB. Right, so that is 30 centimeters square. So that's the area of the triangle ABE. Okay, now that is equal to, and if if you look at the area of the square, okay, and area of the square, if I look at area of the square A, B, C, D, that equals 25 centimeters square. Now what I have to do is I have to break down this area. So we will be breaking down the area into parts. So what does that mean? I'll explain. We'll do area into parts. So what that means is ABE equals ABCF, which is a quadrilateral or trapezium. Okay, so ABCF plus CFE. Okay, because, so do you get it? So it's equal to this one, ABCF, plus this one, CEF. Okay, so, and the square, which is ABCD, equals the same part, ABCF plus this part, ADF. Okay, so, or if we call these equations 1 and 2, so replace, so we can also rewrite the equations as ABE equals 30. So 30 equals ABCF plus CFE, and ABCD equals 25 equals ABCF plus ADF or AFD as in the question. Okay, so AFD. Okay, so this is your 1, this is your 2. Now if I do 1 minus 2 equals, the ABCF cancels out, I get 5 equals CFE minus AFD. So, how much larger is the area of the triangle CEF? The CFE is also CEF, so CEF is 5 plus AFD. So how much larger is the area of the triangle CEF than the area of the triangle AFD? So it is 5 centimeters square larger. Okay, so this is 5, so it's 5 centimeters square larger. That's your answer. Okay, so we move on to the next one, which is look at the diagram on the right. Okay, the side of length of the square ABCD is 9 centimeter. E and F are the midpoints of BC and CD. BF and DE intersect at the point G. What is the area of the quadrilateral ABGD? Right, so then what do I do here? So there are a few points we have to note here. E and F are the midpoints. E is the midpoint. So E is the midpoint, F is the midpoint. BE equals EC. Okay. and because it's a square, okay, and that is also CF equals FD, or BE equals EC equals CF equals FD. So if that's the case, then EF also we have DE equals BF. Now if we do a line joining, which is a diagonal joining the points B and D, BD, so the line BD is joining the points B and D. Line BD is joining the points B and D. So then what we're trying to do is, if you look at now this triangle BDE and the triangle so we want to look at the triangles BDE and equal. So what we want to do is the triangle BDE is equal to triangle BFD, because this is equal to this, BE equal to DF, and DE equal to BF, and BD is the common line, and so they are equal. Also, this triangle is equal BGE, then triangle BGE is equal to triangle DGF, right? So if that's so, then triangle so this part, if you now look at this one, if we now draw another line from C to passing through G and this O, so we draw CO. O is the midpoint of BD. Okay, then you will see that for its BGD is these three parts. Now BGO equals triangle BGO equals triangle OGD. Okay, so what we're trying to establish is that triangle BGD is 2/3 of triangle BED. Okay, it is 2/3 if you look at it. So this part is left out. So this portion is 2/3. Whichever way you look at it, this is 2/3 of triangle BED. So then what happens is, what is the area of triangle BDE? So triangle BDE equals BDE area equals half the base, that is BE 5. Half BE is 9 centimeters, isn't it? So half times BE times the height is CD. CD is the height, okay, because this is 90 degree, okay, so that is equal to half BE is 3 centimeter times, not 3, sorry, 9 by 2, so because it's E is the midpoint and the side of the square is 9, and times height is 9, so that is 81 by 4 centimeter. Okay, now so we are concerned with triangle BGD. So triangle BGD equals 2/3 times 81 out of 4. Okay, so that is 162. No, that's 2. So that is 81 by 6. Okay, centimeter square. Now if you look at this part, that should be half triangle ABD equals half area of square ABCD. Okay, so that equals half times the area of the square is 9, so 9 times 9, so that is 81 by 2. Okay, so what we get is, so the area of the shaded part is shaded part equals 81 by 2 plus 81 by 6, so that is 3 times 2 is 6, 3 times 2 is 6, and 2 is 8, 27 out of 2, that is 2, and 8 and 108, that is 54. So the area of the shaded part is 54 centimeters square. Okay, that is your answer. So it's a bit long, but a bit long-winded, but I think we'll have a go at trying to understand how we can get to this. Okay, so we look at the next one, which is this. And this is telling us on the coordinate plane below, reflect the 2 points A, -2, -5, and B, 2, 5. So we have to first plot the 2 points. So a minus 2 minus 5 minus 2, x is minus 2 and minus 5 is here, 1 and 2 minus 5, 2 minus 5 will be here. Okay, so this is A, this is B, and then on the x-axis, reflect on the x-axis, this will be reflected to get the points M and N. So M will be, it will also be 5 and minus 2. So it's going to be here M, and N will be 2 and 5. 2 and 5. So that's what it is. So we have this. Okay, then translate M and N 5 units to the right to get the points P and Q. Okay, so 5 units to the right. So if we go 5 units to the right, it would be 1, 2, 3, 4, 5. It will come here, and this would be 1, 2, 3, 4, 5. So M becomes P and is Q respectively. A, M, and B, and the quadrilateral APQB. So that would be this, that would be this. Okay, so one is a rectangle, one is a parallelogram. So what is the shape of the quadrilateral? AM and B. AM and B is a rectangle, and this is a parallelogram. Okay. Next is saying find the areas of the quadrilateral A and B and quadrilateral APBQ. APQB, yeah, are they the same? Why or why not? So area of the quadrilateral AM and B. So how many units are there? There's a rectangle, that is length times breadth. So length is, we will have 5 plus 5, 10 times A, M, N, B equals area. Okay, equals 5, 10 times 1, 2, 3, 4. 4 equals 40, and okay, 40, sorry, it's a lot of space. And APBQ, APBQ, so AB and BQ. So again we have 1, 2, 3, 4 times 5, isn't it? Because base times height, base times height, so that equals, the base is 4 times height is still the same, 10, so equals 40. So they've asked why or why not, are they the same? Yes, same. Why is it the same? Because the number of the height or the breadth doesn't change, so the height doesn't change. Same, so I think it's because no change in height. No change in height. So in a quadrilateral you have height, in a rectangle you have breadth. So no change in height or base. Height is, you can say, or base. That's why it's the same. Okay. The next question is point O inside a triangle ABC. The length of perpendicular lines from point O to each side of the triangle is 2 cm and the perimeter of the triangle is 20 cm. What is the area of the triangle ABC? Length of the perpendicular lines from point O to each side of the triangle is 2 cm. So let's draw a triangle. So there is a point O and perpendicular lines to each side. Point O, this is 2, 2, 2. Okay, so we have A, B, C. So if these are the perpendicular lines and they're all 2 cm, then O is the center of the triangle. It has to be they're all 2 cm, they're all equal, isn't it? Of the triangle. Now if you draw a line, extend O to meet the endpoints. So we will extend the line through to meet the endpoints of the triangle. So it's gonna be down, it's gonna be this, it's gonna be this. So it's gonna be, this is what we did, okay? So if you do something like that, then what happens is, now the perimeter of the triangle is 20 centimeter. So AB plus BC plus CA is 20 centimeter. Now you have to find the area of the triangle. So area, now this is, so this equals this, and this equals this, this equals this. It has to happen that way. So the height is, if you now do any one triangle, this is 90 degrees, okay? So height, now if you do any one of these, if I do area of, if I do BOC, or I can write this triangle BOC, it will be half times BC times 2, because area of the triangle of ABC equals triangle BOC plus triangle AOC plus triangle AOB, right? So AOB, AOC, BOC. So if we do BC times 2, BC, similarly area of triangle AOC equals AC. Okay, the same way, triangle AOB equals AB. That's the area. They're all area, by the way. Okay, so I'm using the same ways because it's half times AC is 2 times AC. So the area of ABC equals AB plus BC plus CA, that is 20 centimeters square. So the answer is 20 centimeters square. Okay, so that completes this. The next one is the diagram below shows a right angle isosceles triangle ACB. DE is parallel to BC and DE is equal to 7 centimeters. What is the area of the shaded region BDEC? BDEC. So the area of the shaded region BDEC is what we have to find out. The question says the diagram below shows a right angle isosceles triangle ACB. Okay, so this is my one ACB. It is isosceles. Okay, and DE is parallel to BC. BC is 10 centimeters. DE is 7 centimeters. What is the area of the shaded region BDEC? There are a couple of things we see from the question. One is AB equals AC, and because it is isosceles and DE is parallel to BC, so AD is also equal to AE. Okay, which means BD equal to AC. And then we see that BDEC is a trapezium. So this is 7, this is 7, oh sorry, 7, oh my god, the color is 7, this is 10. So area of trapezium equal to half times base multiplied by height, half times, not base, sorry, sum of sides, that is half times, so that's 7 plus 10 times h. Okay, so the height, if we say this is h, could say this is h, is what we don't know. Okay, so I will not work this whole thing out in this particular video. I'll leave it for you to have a think about it, and we will look at it at a later date. Thank you so much. Thank you for your time, and please leave a comment and saying what you think about the videos, and please like and subscribe if you find them useful. Thank you.